Welcome to Get Your FRQ On. This question is from 2006, Form B, question 4, and it is not calculator active. In the question stem, we're given a rate in which calories are being burned per minute. For somebody who is exercising, there's a graph accompanying this question. In the graph, we have a specific function, f of t, that models the calories burned for 0 to 4 minutes, and piecewise linear functions for values of time between 4 and 24 minutes. In part A of this question, we are asked to find f prime of 22 and to provide the appropriate units. First, note that 22 is not one of the given points on the graph, but it is on a portion of the graph that is linear, so we should be able to find the slope there. F prime of 22 will be 3 minus 15 over 24 minus 20, which is negative 12 fourths, which is negative 3. So F prime of 22 is negative 3 calories per minute per minute. In part B of this question, for the closed interval between 0 and 24, at what time t is f increasing at its greatest rate? And make sure to show your reasoning. The function f will be increasing at its greatest rate somewhere that f prime of x is greater than 0. This happens on the open interval from 0 to 4 and again on the open interval from 12 to 16, so we should be looking there. On the interval from 12 to 16, f prime of x is 15 minus 9 over 16 minus 12, which is equal to 3 halves. On the interval from 0 to 4, f prime of x is negative 3 fourths of t squared plus 3t, which implies that f double prime of t is negative 3 halves t plus 3. Also, f double prime of x is equal to 0 and x is equal to 2. And since f double prime of x is positive on the entire interval from 0 to 2, and f double prime of x is negative on the interval from 2 to 4, f is increasing at its greatest rate on the interval 0 to 4 at x equals 2. And since f prime of 2 is equal to 3, and that is bigger than 3 halves, f is increasing at its greatest rate at x equals 2. For part C of this question, we are asked to find the total number of calories burned over the interval from 6 to 18. The total number of calories burned over the interval from 6 to 18 can be found with the definite integral, the integral from 6 to 18 of f of t dt. The integral from 6 to 18 of f of t dt is equal to 9 times 12 minus 6, plus 1/2 of 4 times 9 plus 15, plus 15 times 18 minus 16. So the integral from 6 to 18 of f of t dt is 9 times 6, plus 2 times 24, plus 2 times 15, which is 54, plus 48, plus 30, which is 132 calories. In part D of this question, setting the function now to f of t plus some constant, calories per minute, find the value of c so that an average of 15 calories per minute is burned during the interval from 6 to 18 minutes. The average calories burned over the interval from 6 to 18 minutes can be found with the formula for the average value of a function. So we're going to get 1 over 18 minus 6 times the integral from 6 to 18 of f of t plus c dt, and we need that to equal 15. So we get 1/12. The integral from 6 to 18 of f of t plus c dt has to equal 15. That implies that the integral from 6 to 18 of f of t plus c dt will equal 180. And that implies that the integral from 6 to 18 of c dt will be 180 minus the integral from 6 to 18 of f of t dt. So we get the equation 12c equals 180 minus 132. Recall we got the 132 in a previous part of this question. 180 minus 32 is 48, so we get the equation 12c equals 48, and therefore c is equal to 4. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.